Alright, so it's me again for this, the final of the videos. So this final example comes from chemistry. Let's take a look. Okay, it actually comes from biology, genetics. It's not so much that I lied, I just changed my mind after I recorded the chemistry version. It seemed like that used a lot of chemistry that it wasn't worth introducing. I could have just, re-recorded the first piece, but hair and makeup and wardrobe is expensive to do again. So, anyway, we have that the rate that space aliens pass along their left-handedness trait follows the differential equation that you see there. That actually is a standard model for passing along traits, not necessarily for space aliens. Now, we will not solve this differential equation by hand, but I would like to see what we can figure out graphically. So the first thing that we should do is find the equilibrium solutions. So you should hit pause while you work on that. And that shouldn't take very long. I'll wait here. Okay, and so what you see, you just set it equal to 0, and since it was nicely factored already for you, you can quickly ascertain that y equals 0, 1, and 3 are the equilibrium solutions. If you think about 0 and 1, they should make sense. For 0, what you're saying is that no one has this left-handed trait. And of course, if no one has the left-handed trait, we assume no one's ever going to get it. So that's an equilibrium solution. Likewise, if everyone is left-handed, y is equal to 1, and that makes sense as well. When you plug in y equals 3, you're kind of stepping outside the model, so don't overthink that too much. It's not like the left-handed people are giving 300% or something weird. Okay, now the next thing I'd like you to do is to take those 3 equilibrium solutions and determine if each one is stable, unstable, or semi-stable. So pause again, please, and try to work that out. Okay, and so you can see in the graph that I sketched a graph of the derivative so you could easily see where it's positive, where it's negative. And so dy dt is positive for y between 0 and 1 and for y greater than 3, and it's negative in the other places. And so what happens is if you start close to 1, dy dt moves you towards 1, and so y becomes a stable equilibrium. On the other hand, if you start at 0 or at 3, you move away from that equilibrium, and that's an unstable equilibrium. So here y1 equals 1 is stable, the other two are unstable. Now, since the realistic solutions would have initial values between 0 and 1, I'd like you to just kind of sketch out some solution curves, see what they would look like between 0 and 1. Okay, so on the left you see some of the solution curves that I drew. You didn't have to draw this many. Well, I'm not collecting it, you didn't have to draw any at all, but I really encourage you to do so. You'll notice that eventually they're all concave down, but some of them start concave up. And so if you're interested in wondering where the concavity changes, I was nice enough to provide another graph. That's my dog. I was nice enough to provide another graph on the right, and that's a graph of the derivative, kind of zoomed in a little bit more than before. And what you can see is that that derivative reaches a maximum at a certain point, somewhere like about halfway between 0 and 1. And so what that tells you is y prime is increasing up to that point. Okay, and so it's going to be concave. So for any y less than that point, less than roughly 1/2, it's going to be concave up. I know my dog seems to disagree, but on the other hand, it's going to be concave down after that. Okay, so in case you're interested, this is the dog that's interfering with your learning right now. I know it's hard to stay mad at her. Now back to the show. Okay, and then this final slide, this can be solved by separation of variables. The trouble is that we have a hard time integrating 1 over 4y, 1 minus y, 3 minus y. But it can be done using a technique we didn't talk about in class called partial fractions. But anyway, this is the solution that you get, that you see down there. It's implicit because I'm not solving that for y. Okay, so this concludes the 4-part series that is Calculus 2, the motion picture. I hope you liked it. If you have any comments, please let me know. It's hopefully you found these entertaining and kind of a different, useful way to learn the material. So I'll be seeing you soon in person.